All right, more chain rule. So we've looked at chain rule. We've looked at some not so miserable chain rule with some sums and a little bit of quotient where we could bring the denominator to the numerator as a negative exponent. We've looked at chain rule with the product rule. Now we're going to look at the chain rule with the quotient rule. In the quotient rule, actually, we have a couple of things that can happen and that we see as we get into the quotient rule. And we'll look at those today. So with the chain rule, and when I talk about the quotient rule with the chain rule, it's going to be when we have two quantities to an exponent. To where before, if you recall, maybe we had an f of x equals 1 over the quantity of x plus 3 to the fifth. And in this example, I told you we ought to just go ahead and bring that x plus 3 to the fifth to the numerator as a negative exponent, and then take and use the chain rule from there so we don't have to worry about the quotient rule. I think personally that it's a little easier to leave this in quotient rule form, especially when we have a quantity that has variables in both the numerator and denominator. Once you bring that x minus 3 to the top, or in the numerator as a negative exponent, then you've got a product rule that's going to happen, and you have a product rule, but within that product rule, you have the chain rule. You have two different chain rules that you have to work with. So personally, whenever I have variables in the numerator and denominator to exponents, I'm going to go ahead and use the quotient rule, but then within the quotient rule, use my chain rule. So let's go ahead and dive into this and remember what we've got, or see what we've got here. So our derivative, quotient rule, recall quotient rule is low d high, less high d low, draw the line, denominator squared we go. So we're going to start with that x minus 3 to the third. Derivative of the top, we have our 2. We have our 2x plus 1 to the first. And then derivative of the inside, all important, that 2 minus less high, 2x plus 1 to the second. And then derivative of the denominator, or d low. So we have our 3, x minus 3 to the second times 1. Not a major deal if you don't write that 1 at the end. I like to put the 1 in there just because it makes you realize, hey, yes, I did find that derivative. Just add a little insurance possibly. And then we have the denominator squared. If I take my exponent of 3 and squaring that entire denominator, I can multiply my exponents. So I get x minus 3 to the sixth. This is going to be what, or to simplify this, we're going to go back and revisit those rational expressions we did at the beginning of the year. So to clean this up, to simplify it, I'm going to look for common factors in the numerator. I should see, well, before we do that, I guess we could go ahead and clean up each of the terms in the numerator. We have 2 times 2, which is our 4, our x minus 3 to the third, and 2x plus 1. From that, we're going to subtract 3 times 1, or 3, and then 2x plus 1 to the second, and x minus 3 to the second. And it's over that denominator of x minus 3 to the sixth. Now we can go ahead and factor out our common factor for the numerator. We should see an x minus 3 to the second. Again, we take out the smallest exponent. We have a 2x plus 1 to the first. We're left with 4 times an x minus 3. I'm going to go ahead and put that as 4x minus 12, distributing that through. Here we have a 2x plus 1 to the second. We're pulling 1 out, so we have a 2x plus 1. The x minus 3's cancel each other out, or they factor out. So we have a negative 3 times 2x plus 1, or a negative 6x minus 3. And that's over our x minus 3 to the sixth. Running out of room, so we're going to make this quick. We have x minus 3 squared times 2x plus 1 times this quantity. Since this x minus 3 is being multiplied to this is a factor of the numerator. We should see that we have a common factor in the numerator and denominator. So we can go ahead and cancel those out. We're going to also go ahead and clean up this bracket. So our final answer, we have 2x plus 1. 4x minus 6x gives us negative 2x. And then minus 15. Oh, I thought I was going to clean it up and be done. X minus 3 to the fourth. I'm going to go ahead and talk about it. I'm not going to do it. But notice we have a negative 2x and a negative 15. We could take a negative out of that, bring it all the way out to the front. Actually, I'm going to go ahead and do it just because I like it a little nicer that way. So we get negative of 2x plus 1, and then 2x plus 15 divided by that x minus 3 to the fourth. And that's really what we want you to get to, a nice, clean, simplified answer. In the second example, I want you to notice that it's set up slightly different than the first. We see in the first we had two different quantities to two different exponents. Here we have two different quantities, but they're to the same exponent. So there's a couple things that you could do with this. You could rewrite it as 3x plus 1 to the third over x plus 2 to the third. Completely legal. We're splitting it up and giving each of those numerator denominators that exponent of 3. And that would make it very similar to what we just did, and then you could work this problem just like we did this one. But with this one, since both quantities, both the numerator and denominator, are to the same exponent, I kind of like doing the chain rule first, and then within the chain rule, I've got a quotient rule. So the way that's going to look is our chain rule brings our 3 to the front, because we have a quantity here. So this is basically just our chain rule. We can bring our 3 to the front. Our inside stays the same. We're not going to change it. We're going to decrease the exponent by 1, which gives us 2. And then we're going to take the derivative of this 3x plus 1 over x plus 2. So that gives us our x plus 2, our low, d high, which is 3, less high, 3x plus 1, d low, which is 1, over the denominator squared. We go. Now we can go ahead and clean up inside this big set of parentheses. So I'm going to leave my 3 up there. I'm also going to break this big fraction, this big rational portion, to the second up. Up. I lost my 3 there. So we have 3 times 3x plus 1 to the second, and that's over x plus 2 to the second. You could think of this 3 as over 1 if you want, or just 3 times that. And then to that, we're going to multiply. Inside there, we have 3 times x, and then 3 times 2. So we get a 3x plus 6. Distribute your negatives, so we get a negative 3x minus 1 over that x plus 2 to the second. We got one more thing that we can do to clean this up just slightly. We have 3x plus 1 to the second. Actually, we got a couple things here. 3x is going to cancel, so we end up with a 5 being multiplied together. We have x plus 2 quantity squared times x plus 2 quantity squared. We add exponents. We're multiplying with a common base. So we get x plus 2 to the fourth. 3 times 5. They're both monomials being multiplied together, so 3 times 5 gives us 15 times 3x plus 1 squared over x plus 2 to the fourth. So that's another way that we can look at it. We can only do this form when the two quantities are to the same exponent. We could not have done that up here because they're not to the same exponent. I have one more example here to end the day. We have a big old nasty radical. Oh, we love them, don't we? So what can we do with that? What do we know about a radical? Well, a radical is, or can be written as, a fractional exponent. So we can write that as the quantity of x plus 1 over x minus 4 to the 1/2. So here I have a quantity to an exponent. So this is going to be more like that second example that we just talked about, where we have that big quantity to the same exponent. So I'm going to go ahead, my derivative, I'm going to bring my exponent to the front. My inside is staying the same. I'm decreasing the exponent by 1. We do get some negative exponents. We can deal with those. And then derivative of the rational here. We have quotient rule. We have low, x minus 4 times 1 minus x plus 1 times the derivative of the bottom, which is 1 over the denominator squared. We go. We can go ahead now and start cleaning this beautiful function up, this beautiful derivative. So we have our 1/2. I'm going to go ahead and break up x plus 1 over x minus 4 to the negative 1/2. I'm also going to make it a positive exponent. So to make a negative exponent positive, we can take that term to the denominator. But we already have a fraction that we're working with. So a negative exponent is going to reciprocate this fraction. So remember, the reciprocal is going to flip that. So we have x minus 4 over x plus 1. Oh, I wanted to break that up. To the 1/2 power. And then we can go ahead and clean this up over here. We have x minus 4 minus x minus 1. And that's over our x minus 4 to the second. We have 1 times x minus 4 to the 1/2. Here, our negative 4 and negative 1 is going to be left over when we cancel out our x's, so we have a negative 5 there. So we have negative 5. Notice our x minus 4's are in common. This is all being multiplied together, so they are common factors within multiplication. So we can cancel out a half of them. If I take 2, I take a half out or factor out a half. I'm left with 3 halves in that. So I get negative 5 divided by 2 times x plus 1 to the 1/2 times x minus 4 to the 3 halves. And that would be a nice clean answer that we would like to get to. And that gives you an example of the quotient rule with the chain rule. Notice we had 2 different ways that we could think about that quotient and chain rule. Good luck!